Florida Municipal Power Agency, it's a municipal power for the state of Florida. We have 13 cities that are members that we provide all of their power requirements for. And that's part of the mission of Treasure Coast Energy Center, is to provide those cities with reliable, economical power. I've worked here almost 19 years. This is a fantastic place to work. I love being in a power plant. I've had time where I was in an office and time in a power plant, and days in a power plant are fantastic days. We have this plant, the Cane Island Power Plant, Sand Lake Energy Center, Mulberry Energy Center, Bartow Energy Center, and then our Stock Island Generating Facility. So a total of 6 power plants are in the FMPA portfolio. At this site we have 2 generators. There's the gas turbine generator, the steam turbine generator. It's called a 1-on-1 combined cycle plant, and it makes approximately 300 megawatts. 160 megawatts from the gas turbine, and then the rest from the steam turbine, and we get that extra power to the steam turbine utilizing a duct burner that's inside the HRSG. The gas turbine makes about 160 megawatts of power. We take the waste heat from that and it goes into the HRSG, the heat recovery steam generator, where it takes this high temperature exhaust gas and reduces it to about 220 degrees by absorption into steam or water to generate steam in a way that we can use it inside of a steam turbine to generate additional power. So as part of what we're doing here, we were looking at ways to make this plant more efficient, more reliable. One of the things that we did was we wanted to install a process to purge the steam turbine generator remotely. We're close to an ocean. The hurricane season, lasts for many, many months, and then if we can operate for a longer period of time before we're required to shut down, that type of thing, it would help us out. So we looked at what can we do on the steam turbine, since it can't be remotely degasified with hydrogen. And as we were looking at that process and the equipment involved in that, one of the operators here was like, hey, why are we just doing the steam turbine? The gas turbine is so much harder, and it's nowhere near as safe to degas as the ST is. The steam turbine's much easier. It's just not remotely operated. So we said, okay, let's see what we can do with that.
So my involvement with Treasure Coast Energy Center was that I was the first one to receive the call saying that they needed help with a DHCP, a dual hydrogen control panel for their combustion turbine. And so I traveled to the site and I met with Chuck Swindle, which was their INC supervisor. And, I basically told him that we could get him the upgrades he needed and get him the unit back up to spec, but that it was better off, upgrading the unit. And while we were there, we discussed upgrading other systems which needed the upgrade as well.
I presented this to my leadership team, and they thought that it was a fantastic idea to do the right thing, to do the safe thing, to do the thing that's going to increase the reliability of this plant, is let the operators be able to control when that happens and remotely from inside this control room, so that it gives us a bigger window to operate in, and then protects them from having to go out into the element to perform this evolution. So part of the equipment that's involved in what we added, or what's already there, is there's a hydrogen storage tubes which we already had that are piped directly into the generator to supply that. And then we had CO2 bottles that were remote as well, but completely inefficient because you can't flow a lot of CO2 because then it ices up. So what we have now is the E1 system with the liquid CO2 bottles, and they are in their own separate rack, which we can just pick up and move and replace anytime that we need to. We can use up all the bottles, remove them, bring in another rack, and have it all set up. So we have that system there. So you have the CO2 bottles, some regulators into what is called the vaporizer. This thing is a magic piece of equipment that is just a beautiful piece of aluminum. It's almost like artwork. Performs this function of taking this liquid CO2 and turn it into a gas without freezing up. And it performs this flawlessly. You can see where it starts to ice up and then dissipates across the different stages, and it works flawlessly through that. And from there, it has some valving and some controls of the flow, and you're measuring some of the flow as well as you purge this generator with the CO2. So we have that there, and also some of the piping was changed so that spool pieces and things that you need to remove. And this is really where the safety of this comes in, and you can see it clearly here is that the spool piece is directly where you can see it. It's not hidden up in this cabinet that you can't hardly get your fingers into to remove it or to replace it, which is even much more difficult. It's right out here in the front. And so we can remove the spool piece, and then you know that there's no hydrogen or any gas inside that generator when we perform that. So the hydrogen control panel is also located right here. And what that does, it just shows you shows you the amount of hydrogen or CO2 that is currently inside the generator. And you can see that visually displayed here. It also controls the valve switching from this panel. We have a ambient operated vaporizer, which means we don't have to have a heater or any kind of electrical power to supply the vaporizer in this E1 platform. What happens is we align the CO2, and when it's changed into a gas in that vaporizer, and how that works for us is this. Prior to having this E1 system to purge the generator, we had to go out there, and it would take us 6 hours to 8 hours to complete this process. Now, from the control room on the Mark 6 DCS, we are able to select the purge platform that we choose. We can either do it in a fast purge or a slower purge. And what used to take 6 to 8 hours is now accomplished in 1 hour. The plant operators love this because the Mark 6E control system, does everything for us. They're used to operating from a control system. They're not standing out there on the concrete in the field to perform this function. They are able to do what they had to do manually from the control room, and it saves a vast amount of time, which increases our reliability and the amount of time that we can operate, because we're not going to have to schedule in that 8-hour purge time before we can actually do work on a generator.
I've been with E1 for 18 years now. It's been a good ride. I'm enjoying it. I love what I do. I think I'm pretty good at it. The part that I like most is putting all the pieces together, evaluating what the customer has, what the customer's needs are, and how we can best put together a solution that's going to make their plant more efficient, safer, and give them what they want and need for the process.